Alright, in this video we're going to look at complex rational expressions. Rational expression, like the previous video, just means there could be fractions. Complex, kind of like what it sounds, it could be complex. Alright, there's fractions within fractions. We're going to look at first an easier example, just as before. Let's take no variables. Right, this is something with some guidance maybe an elementary student could do who's proficient in fractions, but again, they would need some guidance. Alright, I put a 1 here because there are two methods we're going to check out. Nope, don't do that. Two methods we're going to check out to do this. So let me go ahead and rewrite it. Alright, method 1. Basically, we look at the numerator, and this is the method that I claim that an elementary student could do, with some guidance. But we look at the numerator, and we're going to add those two with an LCD, and then we look at the denominator, and we're going to add those with an LCD. So, 1/2 plus 2/3, I know the LCD here would be 6, right? And the LCD in the denominator would be 12. I'm going to skip a step because adding fractions, should be able to do that. But with an LCD of 6, 1/2 is equivalent to 3/6, and 2/3 is equivalent to 4/6. In the denominator, 3/4 would be multiplied by 3 over 3, right? 9/12 minus 4/12. Okay, combining like term, or combine the numerator, combine the denominator, that would be 7/6 divided by 5/12. And notice I said divided by, ultimately that's what a fraction is, right? This means division. Well, really we have 7 divided by 6 divided by 5 divided by 12, that's too much. So, rewriting this, 7/6 divided by 5/12. Now we won't get into why you multiply and do the reciprocal, but remember the rule for division of fractions is we change it to multiply and flip the second. 7/6 multiplied by 12/5. Again, I will always cross cancel, but you don't have to. 6 will go into 6 and 12. 6 goes into 6 once, 12 twice. Multiply that through, we get 7 times 2 is 14. 1 times 5 is 5. 14/5, which does not reduce. Alright, method 2. Now, we hope we get the same thing. We better get the same thing, 14/5. Here's another approach. I'm going to find the LCD of every denominator. I have a 2, a 3, a 4, and a 3. Right? If I looked at all 4 of those, I would notice the, right here, sorry. Okay. I would notice the LCD of everything is 12. Right? If I took all 4 of those numbers, 2, 3, 3, and 4, I know the LCD is 12. So here's what you do. You multiply both the numerator and denominator by 12. We could do that because if we multiply both, right, this is just 1. We're multiplying by a different form of 1, 12 over 12. So, everything gets multiplied by 12. Ultimately, what we're doing is we're clearing the fractions, right? 12 times 1/2. 12 times 1/2 is 6. 2 and 12 cancels to 6, right? 12 times 2/3. Well, let's see, 3 goes into 12 4 times, and then 4 times 2 is 8. So we have 6 plus 8. Denominator. Same thing. Multiply 12, distribute it to both. 12 times 3/4. So 4 goes into 12 3 times, and then 3 times 3 is 9. Right? And then 12 times a negative 1/3 would be negative 4. Okay, 12 times negative 1/3 is negative 4. So 6 plus 8, 14. 9 minus 4 is 5. Done. I don't know about you, but I like that way a lot better. It saved me quite a bit of work. Well, let's look at an example with variables here. More like the assignments you'll be getting. So how about 3 over x minus 2 minus 4 over x plus 2 all over 7 over x squared minus 4. Alright, pretty ugly, right? Complex rational expression. One more thing to note, remember, an expression means we're not going to get like x equals something. We're simplifying this. Alright, so first thing we need to do, get our LCDs, right? In the numerator, LCD is going to be x minus 2, x plus 2. Denominator, I only have one term, so I don't really need an LCD, but I would point out that this does factor, right? It's difference of squares, which happens to be the LCD in the numerator. Planned it that way, especially for method 2. Anyways, alright, numerator, we're working separately, right? I need an x plus 2, so I'm going to take what I have, but I need to multiply that by x plus 2 over x plus 2 minus 4 over x plus 2. Again, multiply by what's missing, x minus 2 over x minus 2. Denominator, I don't have to do anything here, but I am going to change it into a factored form. Anytime you see something that factors, you're going to want to do that. Alright, working with the numerator, we have, let's take this 3 times x plus 2, right? So we have 3x plus 6 over x plus 2, x minus 2. Minus, I'm going to go ahead and take this minus 4, right? We could do minus this whole thing. I want to get rid of that negative now. So minus 4 times x, and then negative 4 times negative 2. Okay, if I do that, I've already messed with the negative. Negative 4x plus 8. And that's why I changed it to plus. You could save the minus for later if you want. You'd have 4x minus 8, right? Anyways. Over that LCD. All over this stuff still. Okay, combining like terms in this numerator. We have a common denominator, so 3x minus 4x is negative x. 6 plus 8, so plus 14 over x plus 2x minus 2 over 7 over x plus 2x minus 2. Remember that a fraction means divide, so we're going to rewrite that. Let's go and go down here. Right, negative x plus 14 over x plus 2, x minus 2, divided by 7 over x plus 2, x minus 2. Divide means change the multiply and flip. Negative x plus 14 multiplied by now I conveniently chose one that would get some canceling because this problem was long enough. Right, both the x plus 2's and the x minus 2's cancel. So our final result is that numerator negative x plus 14 all over 7. That cannot be reduced. Remember, this is a plus, right? So negative x plus 14, I cannot cancel the 7 and 14 unless 7 would divide into everything, but x divided by 7 cannot be simplified. Therefore, 14 over 7 cannot be either. That's it, we're done. Whew, that was a lot of work. Okay, but let's do the same example, method 2. 3 over x minus 2 minus 4 over x plus 2 all over 7. X squared minus 4, let's go and write the factored way. Save ourselves a little bit of work since we already know that, right? X squared minus 4 factors. Okay, so same problem. We're looking for the LCD of everything, just like over here, right? LCD of everything. Well, our LCD of everything, we have an x plus 2, an x plus 2, an x minus 2, x minus 2. So it is this, right? X plus 2, x minus 2. Remember, just like back here, we've multiplied both the numerator and denominator by the LCD of everything. We could see right away there's going to be a lot that cancels. Again, we could do this. X plus 2 over x minus 2, x plus 2 over x minus 2 is just 1, right? It's another form of 1. Okay. Well, when I distribute to this 3 over x minus 2, what happens? These x minus 2's cancel. So I simply have 3 multiplied by that x plus 2. That's what's left. Okay, minus. When I distribute here, let's change colors. When I distribute here, the x plus 2's cancel, so I still have this x minus 2. So minus 4 times x minus 2. Denominator. When we distribute here, everything cancels, right? X plus 2, x plus 2, x minus 2, x minus 2. It's all gone except for this 7. Already in 2 steps, right? I'm about done. Distribute this 3 and this negative 4. 3x plus 6 minus 4x plus 8 all over 7. Combine like terms. 3x minus 4x is negative x. 6 and 8 is 14. And then we have all over 7. They match. Right? Same answers here. Personally, probably 90 to 95% of the time, I'm using method 2. It's quicker and easier. The time I wouldn't, say the LCD for everything is just way too hard to get, then I'd go to method 1. Hope that helps.